The heading is oblique asymptotes, and I said, I just happen to know that x minus 3 is the oblique asymptote. And in the previous one, when I did, we did this one, again I said I happen to know that the oblique asymptote is x minus 1. Y equals x minus 1. So how did I do that? Okay. The first thing I want to draw your attention back to is that when I started you with this guy, I believe it was this one. Okay, this is I think what we started off the morning with. Okay, I knew that it would approach y equals x because you've got this part here, which is approaching 0, right? Does that make sense? So all you get left with is this part. Okay, so the short answer to how do you find the oblique asymptote for something messy like that or that is you need to get this kind of situation. You need to isolate out the part that approaches 0, and then whatever is left will be your oblique asymptote, okay? Or whatever asymptote, as you'll see in a second, there are other kinds, okay? So this is what we're working toward, right? So keep that in your head. I'm trying to isolate that guy, or something that looks like it. Keep in mind, if it was like a 2, or a 23, or a 230, even though that number looks much bigger, it's still approaching 0. Does that make sense? Because I'm getting positive and negative infinity on the bottom, right? So no constant number can hold a candle to infinity. So it's still approaching 0. So the question is, what must I do to this thing in order to get there, okay?
Expand the brackets.
Okay, so I've picked this example to do first before we go to this guy because it's easier because of what you have on your denominator, okay? So let's expand the brackets. I'm going to get x squared, negative 2 and 1, they add to minus 1, so I have minus x in there, and then minus 2 times 1 is minus 2. So there's my numerator, okay? And all of that is still divided by x because I haven't done anything to the denominator so far, okay? Now because all I'm doing is dividing by x, this is a super easy example, okay? Watch how easily this x minus 1 falls out, okay? Do you agree that if I've got these three things on the numerator, I can write this one fraction, sort of go in reverse, and I can write it as 3 fractions. Do you agree with that? I can write it as x squared on x, minus x on x, minus 2 on x. Is that all right? One fraction, I've just broken it into pieces. Okay, and this breaking into pieces is a very, very useful thing, all the way up into 4-unit calculus and integration and stuff like that. Breaking up fractions can be very useful. For example, because I'm about to do this. X squared on x, x. X on x, 1. There he is, right there. He's just sitting there, right? There is the oblique asymptote. 2 on x, it's going to approach 0. Right? It's going to approach 0. Okay. By the way, you know how we were talking about this, right? How you're approaching from the top on this side, and you're approaching on the bottom, from the bottom on this side, right? Well, whether this is a minus or a plus will tell you whether you approach from the top or the bottom, okay? And in our case, we were approaching from the bottom because it's a minus, okay, so you got a positive thing. So, that's really easy. It's really easy because the denominator was just x, and often it will be, so this technique is really great, it's very fast, okay? But it won't cut it when you get a guy like that, right? So this is y equals, again, let's expand that because we will need to. We've got this, okay, so I can't just simply break it apart and then cancel. I will do that in a second, but I need some more sophisticated tools. And the sophisticated tool that we need is called, where's my blue one? Here we go. Polynomial division. Polynomial division. Now, polynomial division, I should say polynomial long division, is just like normal long division, like with numbers. Okay, so let me remind you, because it's been a while, okay, if I suppose gave you this, how would we do this? 7 into 300, what would I do? First step, yep.
Sorry, see how many times 7 goes into 30?
Okay, that's the second step. I'd say how many times it goes into 3, but you of course know it doesn't go into 3, so that's why you go into 30. And the answer is how many times? 4 times. Right, the 4 there. And then what do I do with that 4? I multiply back by my original divisor, and that gives me 28. And then what do I do? And then I subtract. Now what?
Bring down the 0.
Well, the reason why I bring down the 0 is because I ask, how many times does 7 go into 2? And the answer is no times. Right, it doesn't go. So that's why you bring down the 0. And then I say, how many times into 20? Twice. right? And now what do I do with that? That's 14. So what does this 6 mean?
6 on 7.
Okay, so you can either say 300 on 7 is 42 and 6/7. That's one way of saying it. Or you could say, and this is going to be more useful to us, 300 divided by 7 is 42, remainder 6. Is that okay? Or if you want to write it the other way, 300 is 7 by 42 plus 6. Okay, and actually, this is going to be very helpful to us. All right, now, don't freak out, right? It's just algebra. I'm going to do the same thing, but with polynomials. Okay, instead of numbers, polynomials, right? So this is, so this is what I'm dividing by. Okay, just like it's 300 over 7, I'm dividing by x plus 1. Okay, so I'll stick that x plus 1 out the front. Okay, that's my divisor. And then what I've got over here is the thing that I am dividing. Okay, that's x squared minus 2x, and just for the sake of it, I do need to put on the end here that there is 0 left over. Okay, if there was like x squared minus 2, I'd have to have 0x in there. We know that because, like, look, these zeros here, they matter, right? Just like the zeros here matter. Okay, now this bit's a bit tricky. In the scheme of things, remember, this x, it could be anything. Could be anything, right? It could be, say, 1,000,000, right? Or it could be 2, okay? So therefore, when I'm dividing these things, right, all that really matters is the x. Like, how many times does the x fit into, and then I go step by step. So, how many times does x fit into this guy?
X.
X times. Stop. Just make sure you get this, right? Don't just machine through this mechanically. What have I done? Just like I asked how many times does 7 go into 30, I'm asking how many times x goes into x squared. Like how many times does 5 go into 25? Or how many times does 6 go into 36? And the answer is it goes x times. Okay? What do I do with this now? Think back to what we did before. I take this guy, just like I took this 4, and I multiply it back, right? I multiply it back by this whole thing, which gives me x squared plus x. You see that? X times 1, it's just x. So far, so good? Now what do?
You subtract.
I subtract. Just be so careful with your signs here. Okay, I subtract. So minus 2x minus x gives me minus 3x. Okay? Plus 0 down here. Okay. So now that I've gotten to this point, I ask the same question. My cycle begins again. How many times does x go into that? Answer, minus 3 times. Okay. So then I multiply back, gives me this, which means my remainder is, I take this away, don't I? And it's a double negative, so it's a 3. I'm subtracting negative 3. Okay. Now coming back to this line up here, this line. Oh, that's an equal sign. That's really messy. Okay. How would I write this line, but this time in polynomial talk, right? Yeah.
Y equals x plus 1 times...
Okay, hold on.
That one.
Yeah. Okay, so what I'm going to start with is, what's the big number? What's the thing that I was dividing? And the answer is x squared minus 2x. Okay. And what this is telling me is that it's equal to this times this minus plus that. Okay. And we can just check that out because I can just expand this, right? What's this? This is going to be x squared plus...
Minus 2x.
Well, yeah, minus 2x minus 3 plus 3. So these guys go, and this is what I expected. Sweet, it worked. Okay? So what was the point of doing that? Why is rephrasing this so useful? And the answer is, so you can do this. Ready? Watch. I spent all that time rephrasing my numerator. Okay, so really I know now it's this. Maybe the cogs are turning. You can see what this is going to do. See that? I've just rewritten the numerator. All that long division stuff was just so I could rewrite the numerator. But now it's in a position where I can break it apart. See it? I can break it apart. I'll do it with all the steps. There's x minus 3. And there's x plus 1. You see? I've split it apart, and now it's in a form that can cancel. And all you get left without the front is that x minus 3 plus this guy who just disappears off to 0 as I approach positive and negative infinity.